Good morning and welcome back to another Micrographics and Autodesk webinar. Today's topic is a deep dive into creation of factory assets. This is a follow-up on our previous webinar where we had a look at the factory design utilities that is part of the design and manufacturing collection. I'm your host for today, Carl van Rooyen, application engineer with Micrographics. So having a look at the agenda for today, we are going to be covering a quick introduction on what we will be covering throughout the course of this webinar and why we would be wanting to create our own assets. We'll then have a look at what our asset requirements are, the model prep to be able to get the model prepared for use within the asset sort of creation environment, the asset builder, then setup and publishing of an asset, basically getting the asset once again set up correctly with all the correct connectors and information. And then last thing we'll look at is the asset use. So once we've created the asset, how can we then use that in our factory layout? And then we'll close off with a summary and Q&A session. So into our introduction, we'll have a look at the assets, and one of the biggest questions might be, well, why do we want to create our own assets? Because there is an existing library of, or should I say, there is an existing asset library that comes with the software. Now, this existing library is quite a large library. It's got a big variety of components within it. However, these are mostly common objects. If we look at sort of the image on the right here, we've got common objects like safety fencing, conveyor belts of different types, material handling, very generic equipment and assets within that library. And you might find that you need to start including more custom objects within your layout. It could be machinery that you design in-house or machinery that you purchase and bring in that is not within that library. So that library is not complete. And you'll be able to want to create your own. You want to be able to reuse machinery that you developed and produce or that you buy in within your layouts. And by creating your own assets to put into the library, you can create a more industry-specific library for yourself with your components that you use, your equipment that you use, and you can quite easily bring those assets into your design, into your layout, and reuse them quickly and easily. And the nice thing about creating your own assets is that these custom assets can be a 3D model as well as their counterpart 2D for the 2D layouts. And because these are custom assets, we can build in custom behaviors into them. So as you create the model, you're able to set up the parameters, you're able to set up rules that adjust the model as you change it for the client's requirements. So we're going to be looking through the process of how do we create your own assets and put them into your library. And the first step is the requirements of the asset itself. We need to start with something. And the easiest there is to start from a 3D model. Now, you may already have a 3D model of your design, and we can take that and we can then essentially simplify that down, or you can simplify that down and create a simplified part that can be used. In this case here, the image in the middle is an existing packaging assembly line, and it's simplified down just into a single part. It could also be an assembly. You could take an existing assembly and create an asset from that. And that part or assembly could be A fixed model, essentially the packaging machine here that I've got, there's no parameters to drive it. It's at fixed size. Essentially, that is the spatial requirement for it, that machine as it is. That's how it's sold off the shelf. And so it's a fixed model. There's no changes required to that. But you can also have your models customizable. On the right-hand side, I've got a bit of a cooling line there, and that is driven by parameters to adjust the length, the width, the height. And so the 3D model we're starting off there is a bit more flexible, a bit more customizable. You can even build our logic into your models to give your users specific options, or to simplify the user input. So you could have our logic rules that calculate how many fans are required on the side of this cooling line. It could adjust the roller spacing or roller diameter depending on the width or the length or the height of the cooling line. So these models can be highly customizable and driven to update according to the input that is put in there. So from an asset requirement perspective, we can either put in just a single part, or we can put in an entire assembly into the asset library. But there does need to be some preparation. From the parameter side and the iLogic side, as I mentioned, we can set these models up so that they are highly customizable. So in this case, the model that I've got is just parameter driven. There are a couple of key parameters. We have the overall length, width, and height of the cooling line. And some of these might be multi-value parameters. So your length, you may have 3 different length options or width options, and those can be adjusted as needed. And can also, some of the parameters can also be equation driven to minimize user input, but to even further minimize user input, you can drive that design through our logic. As mentioned on the previous slide, if we adjust the length, we can have an iLogic rule that then adjusts the number of fans or the number of rollers within the piece of equipment. And so iLogic can control and drive aspects of the asset, of the design, so that when the user makes simple changes like the required length or the required width, the rest of the design update can be automated. Good example would be making this wider. The roller's diameter may need to increase so that you've got a stiffer roller so that you don't get deflection on those rollers inside this component going across the width. So from model requirements and the model prep side of things, we do need to basically have just a part or an assembly, and it can be fixed where you put it in there and that's it. It doesn't change size or shape. There's, let's say, no options available, or it can be highly customizable or parameter or rule driven. So as an example here, we're going to jump into a demo and go into Inventor. And I would typically start with the Inventor model, as this is going to be the easiest place to start, and then generate a 2D from this for the use on the 2D layout side. And we see here I have got a design where we have some rollers inside. This is basically a cooling line product that is produced in one long linear sort of strand, can be woven over and under the rollers to work its way through the cooling line and cool down as it goes through there. Now, from a design perspective here, I've kept the design simple, just to represent the overall envelope. If this is going into a large facility where there may be multiples of these plus other machinery, you do want to keep the design as simple and basic as possible to help with performance on the large layout, on the facility layout. And you'll see in the asset library as well, a lot of the standard assets are very basic stripped down assets that give you more of a spatial requirement than a design requirement. So in this case here, you'll see they're not actual fans, but they do just represent fans on the side of the cooling unit. So we can kind of get an idea of what this is. Now, from a design perspective, if I go into parameters here, we will see that we have length, width, and I've got cooler height for the height of the entire cooler, and then I've also got height for the essentially the feed height or the height of this lip here. This one will come into play a little bit later on. We'll talk about that. But if I go ahead and look at the length, I've got a multi-list parameter here, a multi-value parameter, and I can change it from 5 meters to 10 meters, and the model in the background updates to show that change, and I can change it to 15 meters. And the model itself is flexible enough and designed in such a way that the patterns or the components or bodies will shrink and grow with the design or with the changes in the parameters. We can do some things like changing the fan diameter, and the model will update according to that change. Now, these parameters can then be used to drive the asset going forwards. So think about what you may need to change. If the customer needs more cooling performance out of the same size unit, they may want to increase, you may need to increase the fan diameter. So that may be something that you would want to be able to change once the factory asset is created and placed. So think ahead to what customizations are required. Those customizations need to be catered for during the creation of the model. And so things like the fan diameter, if I go ahead and go from a 500 to a 600, we can then have that diameter update. Once again, this could be a multi-value to allow the user to choose from a drop-down list, or there could be our logic that checks for the size that you input and could warn you maybe it's too small or it's too big, and it adjusts back to a standard diameter automatically. So think about that automation process of the design to create that nice flexible model. Then a couple of things we will need to consider when we go through the setup in the setup builder that we'll move into next is also some geometry that we may need to add onto the component itself. Just want to highlight something here as well. I've also got two little cylinders that represent plumbing fixtures. It basically just be like a line in and a line out for coolant, and that can come in handy on the asset building side as well. So from a model prep perspective, we want to be able to have a model that you can update parameters. If it is a flexible, customizable product, then you need to be able to change those parameters and have it flex and change and be customized as required. So I'm going to jump back into the slideshow, and here we will look at the setup on the asset builder itself. So what do we need to do to set up the asset before we actually publish this into the library? Now, we have a couple of things that the Factory Design Utilities does for you. I need to explain that a little bit first before we explain on the asset side. For those of you that are not too familiar with the Factory Design Utilities, essentially when you create a factory assembly, you have a ground plane, and anything that you bring into that assembly will want to snap to the ground. Now, for a piece of equipment to snap to the ground, we need to specify its landing surface. So this would be the foot of the object, so the feet that it's going to stand on. It could be a base. If it's a base made of I-beams, we're going to select the underside of that part, the underside of that I-beam to place it in. That would be the landing surface. If it is something like lighting or an object that hangs from a ceiling, and you have a set height that you want that to hang at, you can create a work plane that represents the ground and then a parameter from the bottom of the object to that work plane, so that you can adjust the height between the work plane, which would be your ground, and the object that you're designing. And that can be a parameter that the user can modify, but the work plane would be what we call the landing surface. The underside of the feet of a table or a machine would be the landing surface. So any foot that is touching the ground would essentially be considered your landing surface. So that represents the base of the asset, the bottom of the asset. And on this, we will also specify an insertion point. Essentially, where is the asset attached to your cursor? So we could have the insertion point on the image on the right here, that midpoint along the bottom edge of the model. And so the cursor would be attached to that point when you move the asset around in your assembly, when you're inserting it. Then secondly, we need to specify a connector. Now, what Factory Design Utilities does during the design and layout process is it simplifies the assembly of components. We can basically snap these components together using connectors. So if you have conveyor belts that need to snap end to end, basically the connector from the end of the first conveyor belt snaps to the connector to the beginning of the second conveyor belt. And so these connection points allow for basic or very quick and easy assembly of the different assets in your layout. So we need to specify the connection point. Where on the model is that connector going to be? And in this case, we can see here on the right-hand side, I've got a connector showing there on the cooling line. The large red arrow is the direction of the connector. So that is going to connect in that direction to another object. The blue arrow showing the up direction for the connector. So it's important to pay attention to that. Otherwise, your machine may flip over and connect upside down to something. Or the object you connect to it could flip over and be upside down. So you set up your connection point and the direction of the connector that you want to use. From there, you would then move on to the rest of the setup for the asset itself. And this is where we would set up asset properties. Here we have the ability to update our properties. So we can go in under asset properties and fill in information under your typical R property tabs. Things like your summary information, title, subject. If you go over to project, you'd have your part number, your description, your stock codes. You'd be able to fill that information in there as well. And then we also have a new tab there that is not a typical R property, but this is called the descriptor. And the descriptor can be built up according to the parameters that are being used in the model. So we can see here one of the parameters for the model is the length. So the descriptor there is length and then some fixed text cooling line. So depending on which length you choose for the cooling line, the value will update. We can see the extended descriptor there showing length, width, height, and then cooling line. So you're able to set up these descriptors. They describe the object, but they are actually linked to the parameters that are being used for that object. We also have layer information to put that object down on a specific layer when it is inserted into the design. And then we also have customizable properties, basically your custom R properties that can be added as well to the design. Once you've set up properties, the next part of the asset builder you can go through is the 2D sketch option. So basically we've got the 3D model, what 2D sketch do we want to use with this 3D model? And we have a couple of options there. Basically, we can generate from the existing model itself. So you're basically using a top view of that model to generate a 2D sketch, or we can import a DWG file as the sketch and use that as basically the block of the sketch that represents this part in 2D. So we can see here that packaging machine I spoke about earlier. There's our top view sketch of that. That block would then represent that object in a 2D view. Then moving on further into the setup of the asset, we also need to select our key parameters. So the image actually there on the bottom right hand side, we can choose which of the parameters for the design are exposed in the asset library for the user to be able to modify. So by ticking the key column for length, width, and height, those parameters would then be exposed and visible to the user to modify as required when they drop the asset into the layout. And so they can then change the length of the cooling line. Part of the key parameter setup and modification is creating asset variants. If this asset that you're building comes in different variants, we can create those variants. We can predefine those variants using the key parameters. So we see we've got at the bottom length, width, height selected as key parameters. Then in the asset variants, we've got those parameters listed as well. And so here now we can create our variant. The table at the bottom, I've got short, medium, long variants. And if we see on the right hand side, I've added the length and the height parameters. So for the short cooling line, because there is less length to use for cooling, we've increased the height of the cooling line. So we can still fit, let's say, the same amount of material in that cooling line, but we've got a short distance to be able to fit it into. So there we have short, medium, and long options for this asset. And as the length changes, so does the height of the unit. So the asset variance allows you to create different sizing options or configurations where you combine changes in parameters to allow for the user to quite quickly and easily just click a drop down and choose which variant they want, and the parameters adjust according to their selection. So another quick and easy way, or another way to ensure that it is quick and easy for the user to insert the variant or the option that they want in the design. And then lastly on this slide, before we jump into a demo and we go through this step by step, is BIM content. We can also set up things like MEP connectors onto our machinery. So I highlighted these two little cylinders on the side of my machine, and I mentioned those would be plumbing, water inlet and outlet for the cooling line. And so as part of the asset creation, we can also set up our BIM connectors. So our MEP connectors, should I say. And so in this case here, we set up a pipe connector to have cooling water going in and out of the system. So that brings us to demo time. I'm going to jump back into Inventor. And over here, we'll now go to the asset builder. So basically here in our 3D modeling environment, I've got a part open. I'm able to go over to create asset, and there is the asset builder option here. Entering into the asset builder will firstly bring up the key parameters window. Here under key parameters, as mentioned, you can choose the parameters that you wish to sort of expose and adjust as needed. So I'm going to go ahead and choose length, width, and height. These are the parameters that I want to be able to adjust. I'm going to do cooler height as well. I have two height values. One height is for the lip at the bottom of the cooler, and the second height is the overall height. You can then also put in some descriptions here, or should I say the factory name. This would be what shows within the asset library itself. So when you select an asset and that brings up the properties, you would see the actual unit width. So the height here, sorry, not unit width, that's unit height. And at the bottom here, this is going to be conveyor height. And so you can put in what the user would see the name as, so they would be changing the unit length, and there can also be a tooltip to explain what that parameter is going to be changing. So once you've gone through, select the key parameters that you want for your design. You can close that window off and then start here. Basically, easiest is to start on the asset builder from the left. As I mentioned, we'll do a landing surface, and I'm just going to pick the underside of the part. That is going to tell us that is the bottom of the piece of equipment that will sit on the floor. You can offset this if you do wish, and you can also flip the direction to set that up or down. So you'll see the Z-axis representing our up direction. You can also adjust your insertion point. By default, it will be at the origin. If I want to, I can go here to the end of the part. I'm just having a look. Okay, seems like my work point there has disappeared. So let me just go back. Just double check. Let me add a work point quickly. I'm just going to add a work point to the bottom center there, and I can then use that work point to then specify the insertion point. So there's the insertion point for our object. And so under landing surface, we'll set landing plane insertion point. So we can see the insertion point relative to the part. And then under define connector, once you click that, it looks like nothing happens, but essentially you're able to go to your model and select either a face, you can select a work point, you can select the midpoint of an edge. Basically, whatever you highlight, it's going to find a point, let's say the centroid, and that point is going to be your connector. Now, selecting my point to connect where the conveyor belt would connect to feed this has given me the connected direction. So I've got the large red axis there, but the blue is our up direction. That is not correct. So clicking on that axis and then clicking a reference will rotate that arrow perpendicular to the reference. So I'm going to choose the top surface of the piece of equipment, the cooling line, to set our up direction. If you right click, you'll see you've got a couple of options. I'm going to hit OK to create that connector, and the connector dot is created, and we can then redefine the next connector, do the same thing there, and right click OK. So here now I've got connector 3 and connector 4. I had previously created 1 and 2, but we can rename this. So I'm going to say conveyor in for our first connector, and second connector conveyor out. So there we have our connectors. Part of defining the connector is setting up a connector class property. Now I'm going to have conveyor belts connecting to this. So I would like to set up connector class as a conveyor. So we'll click the drop down, select conveyor, and then under family type, we can choose the type of conveyor. So I'm going to have normal conveyors connecting into this. So we'll choose normal, and then you would normally choose add. I've previously done this, so it is loaded in here already, but we would add it. If I delete this here, we can see it will add, and that adds that as a connector type. Now, what the connector class property does here is it allows parameters to be passed from one object to another. So the conveyors, their connector class property is set up as I just did now, and the conveyor belt width can then be passed on to the width parameter for the cooling line. Same thing with the height. So I have this connector here which has the height parameter. So if I connect a conveyor belt to this, the height of the conveyor belt should adjust to that height, and the same with the width. So the connector class properties, if two objects are connected together and they have the matching connector classes, parameters can be passed from that one object to the next object. If you have used factory design utilities and you've put down a couple of conveyor belts connected together, then you would find that when you adjust the width on one, the entire string of conveyors updates. That is what the connector class property is handling there. So not only do you define your connectors and where your connectors are, but you also define the properties for those connectors. Under asset properties here, I'm not going to go in and adjust much here. I've got part number, descriptor was already set up. And I'm just going to go over to customizable here, basically like you would add custom R properties. I'm just going to put in something like power consumption. It's a text value. I'm going to add that in, and I'm going to leave the value there blank for now. Then under asset variance, this is where you'll adjust the variations or set up the variance. So let's say that length and the height was going to adjust according to the variation. So I'm going to add length and height, and I'm going to click plus to add a variant. So I'll quickly add in the short. That was 5 meters with a height of 3 meters. Sorry, it's not the height that I want. It was the cooler height. So I'm just going to take that height out and put in the cooler height. And cooler height was 3 meters. The height, that option for just height, was the height of the connector. So I'm going to add short, medium, and here we got our drop down. Because it's a multi-value parameter, we can have a drop down there to select our different options, short, medium, and long. And so the long will grab the 15 meter option there, and let's make this 1.5 meters. So you can add various parameters into the asset variant list. Click the plus, adjust the variant name and the parameters as needed, and that allows you to then place or have the option for the user to choose which variant, and then automatically the parameters are adjusted as required. So that is the variant setup. And then lastly, I'm going to go to the BIM content, and we see the BIM content here is actually set up already, basically choosing the pipe option. We go ahead and edit here. Choosing the pipe option would bring up the ability to add a pipe connector. So you would choose the shape, the location, and if I just go ahead and edit connector 1 here, we will see we've set up the nominal diameter and then the system type. So there's some information there with regards to the system. So we've got flow direction in, connection type is flange, and then connector 2, we've got flow direction out, connection type brazed. I'm going to change that to flanged. And so we now have our BIM connectors set up here as well. So from a model perspective, I've gone the extra little mile here and added a couple of things, but bare minimum, you would need landing surface and connectors. And then your key parameters if there need to be any changes. So if I bring up the key parameters window again, enabling key parameters, that would be bare minimum. I've gone through, added a couple of other options. This gets us to the point where we are now ready to essentially publish the asset. So I'm going to jump back quickly into the presentation. And what we'll do here during the publishing of the asset is we will give it some general information. So the name that we're going to publish it under, the asset name. What type of asset is it? So we've got standard, pit, or platform. So standard would be any machinery that goes on the ground. Pit goes under the ground, platform goes above the ground. So we can categorize the asset type there as well. There's a thumbnail, we can use the default or a current view. So you can adjust your view and take the current view. And then below we have the destination. So you can have this as a local asset stored locally on your hard drive, or you can set it up as a cloud asset stored in the cloud. This allows you to not worry if your PC crashes or you uninstall the software and reinstall. You're not going to lose those assets if they are stored in the cloud. And you can create folders using the plus on the right hand side to create multiple folders to categorize your equipment even further. Then part of the publishing process is also the output options. So for 3D, we can generate a Navisworks model. From a 2D perspective there, we can publish the 2D asset, and we have various options here on how to publish that 2D asset. So we can use a sketch within Inventor to output the 2D asset. Otherwise, we can use a view projection, and it will create that, essentially that 2D block from that view projection, or we can take a DWG file. So here I've actually had a cooling line.dwg created, and we can use that DWG as the existing block to represent the cooling line. So you've got various options there for the output. And then lastly, bill of materials. I didn't include it here, but essentially your Inventor bill of materials, is it purchased, is it normal, is it phantom? Those standard options, you're just basically choosing how does this asset populate in your bill of materials. Okay, so I need to go into a demo here. I see I missed the demo slide, so I'm just going to jump back in here. Very last thing here under Asset Builder is to publish the asset. It's going to prompt you to save, and we can then go through and adjust. I'm going to go there, Enable Cloud, choose the folder, and this is going to be cooling line. I'm just going to call this demo. And under options, you would go and fill out your options. So here, these are predefined. I'm going to keep it as is. There's the bomb structure, normal. Happy with that. And we'll hit OK, and that goes through the publishing process. That will publish to the library. So we'll give that a few seconds to publish. Doesn't take very long. It generates all the necessary files, uploads to the cloud, and from there what we can do is we can go back to, let's say, creating a new factory layout. As I mentioned, there is our ground plane in the factory layout. If I go to Cloud Assets, Test Equipment, you can see one I did earlier as a test, and then we've got the one that we just did now. So if I double click on that one and place it down, right click done, we'll see we have that asset variant. Selecting the asset once it's placed down gives you the options to be able to adjust your values. So here we have the conveyor height. This was the connection point to where the conveyor would be. So if we adjust that to 750 and update, we see that connection update. The variant, we've got short, medium, and long. If I go to the medium variant, once again hit update, the asset will then update. And as mentioned, if I did everything correct, if I now go and add a conveyor belt to this, go ahead to System Assets, Conveyors. I'm going to go to Belt and put in a straight belt. We connect those two. We'll see that the conveyor belt updates to match the width of the asset. Click here, the height of the conveyor belt 750. If I go to my asset there, also conveyor height 750. So we'll reduce that to 500 and update. We'll see that change. There we go. Conveyor also updates. So that's that connector class working there, ensuring that your custom asset is also able to talk to the existing standard assets out the box as well. Once again, your users, as you're placing these assets in, can then be changing the parameters as required to customize the cooling line or the asset to their requirements or to the client's requirements. So that there brings us to that asset use. Basically, as we saw there, we can place and modify the assets it places directly onto the factory floor using your landing surface as a reference. It can easily assemble with other components using those connectors. I actually want to grab that asset again. I'm going to bring in that cooling line, and you'll see that I can connect it to that existing cooling line. And in this case, the overall height is not one, let's say, parameter that's being added in there, or the variant. So I can go in and adjust as needed here. Let's say we go to medium and rebuild, but the width has updated so that the width and the connecting height between the two is correct. So we can easily assemble the components together with the connectors, and we can adjust using the factory properties, choosing the variants, choosing the different parameters needed, and we can then also review the asset properties. So we got the project properties there, the part number, description. You'll see further down, uncategorized power requirement. That was the property, that custom property that was added. And then also we'll see the descriptors showing there as well. And the descriptors will update automatically depending on the asset properties. So we can see here descriptor, basically 10 meters by 1.2 by 500 in the descriptor there. So that 500 referencing the height of the connection to the conveyor belt. So when we get into the asset use within large assemblies, this is going to basically speed up or make it quick to do layout creation with your own machinery. As your machinery or equipment is added to the asset library, you're able to quickly and easily grab it from that library, adjust certain parameters that are, let's say, set by your client, and you can easily drag and drop your equipment in, have it connected together, allowing you to reuse your custom machinery quite quickly and adjust to those customer requirements. And this also makes it perfect for RFQs, where your client has a request for a quote and you need to get information to them as quick as possible, or you need to get a proposal to them. It doesn't have to be an exact, everything's designed perfect, but you need to show them a proposed layout. This is perfect for being able to modify sort of generic equipment that you have created and put in that library to show what is possible, what you can do. So I've actually jumped a little bit ahead, done the demo already. So I'm going to go onto the summary slide. Now, before I do close off on the summary, I'm just looking at time. We're not doing too badly on time. I'm just going to go back here to the packaging machine. And the process here on the packaging machine would pretty much be the same. I'm not going to run through that entire process again, but just to show you here, this as an example, it's actually an Autodesk data set from, I think, from Inventor 2022, but I've done a simplify on this. So from the assembly, I went in and did a simplify model and chose to remove certain portions of the assembly. There were a lot of cardboard boxes, wheels, belts, pulleys, and I've removed all of that information. These used to be extruded parts. They're just replaced with blocks. So this is a very simplified down assembly that can be used to create an asset from. So I've got a connector point there for the conveyor belt to another conveyor belt that can be added. And so this model here would essentially be a fixed model. This will come in as it is, no parameters, no variants. We just create a landing surface, a connector, and publish that out into the asset library. And we would then be able to bring it into the factory layout itself. So just another example there, you could take existing equipment and strip it down and publish that as an asset to then be able to use within your larger main assemblies or layouts. So with that being said, I'm going to do a quick summary, and then we'll open up for any questions on the live chat. If you do have any questions, you can just fill them in so long on the live chat, and then I can cover them once I have got through the summary. So just a very quick summary. The factory design utilities brings in a large asset library. However, this asset library is typically common use assets that may not meet your requirements. It wouldn't have any, let's say, very industry specific machinery, and so you're able to create your own and expand that asset library and tailor your own custom library to allow you to then quickly create layouts with your own machinery. And that brings me to the second part there. When you're doing large layouts or assemblies, as I said, it allows you to quickly pull in those assets, place them down on that layout, and generate a very quick layout, and also easily reuse and customize your assets to show a customer on an RFQ or a submission to them to show, listen, this is what we can do. And it helps with a quicker quotation cycle as well. You submit to the client, this is our proposal. It allows for that process to be a lot quicker, easier, and smoother. So that just brings us to a close on this presentation. Basically creating your own custom assets within Inventor to then add to the asset library. I'm going to open up for Q&A. I haven't seen anything come through in the live chat. I'm just going to give a little bit of time here to see if there is anything that's going to come through. And we'll answer those questions as they come through. I'll just give a minute or two. If nothing comes through, then we'll close off the presentation. Okay, so I see there's no questions come through yet on live chat. So what I'm going to do is I'm going to close off this presentation. Just by saying thanks for watching, whether you tuned in live or you watched the recording after the fact. Once again, this has been a webinar brought to you by Micrographics. Please like and subscribe to our YouTube channel. We have multiple technical resources that do webinars on a regular basis, both in the manufacturing and architectural spheres. So please have a look around the YouTube channel, see what videos there are there. We've got a lot of tips and tricks videos, as well as longer format webinars that go more deeper into specific topics. But once again, my name's Carl van Rooyen, application engineer at Micrographics. Please like and subscribe to our YouTube channel. Share it if you feel that you know anyone that will benefit from it. And if you do want to get hold of us, we have our website, mgfx.co.za, as well as our email address, info@mgfx.co.za, both up on screen. Feel free to contact us with any questions, and you will be directed to the correct person to help you out. Thank you for tuning in, and I hope you have an enjoyable day. Cheers.